Hey everyone, welcome back to our channel. I'm Umesh Gupta. In this video, we are going to talk about a question from AWS Frontend Interview Process. We are going to implement a functionality called deep filter, and this question is a good problem statement to practice problem solving skills in the front end space. Before starting with this question, I would request you to watch the video till the end and make a call that if my content is adding value, then please help us raise awareness around our content by liking, sharing, and talking about it with your friends. So without wasting any time, let's get started. So let's take a look at the problem statement here. It says that we need to implement a function that takes two arguments, an object and a filter function, then return, and it should return a filtered object. So what's the syntax? Let's check out the syntax. It says that there is the filter method which we are already seeing here in the ID. It takes two parameters, a collection and a callback. Let's talk about the arguments. So let's zoom in a bit. So collection is basically an object, the collection to iterate over, and callback is a function that returns a boolean. So this function is invoked on every element. Okay, so we have the signature of our function is that it takes two parameters and it returns an object. Okay, let's take a look at a couple of examples to understand better. So we have this input object where we have this key A with the value 1 and B, that's an object and it's a nested object. Okay, and our callback is a function that filters out all the non-negative, basically positive elements, 0 and above. Okay, and this is the filter function where there would be some defiltering logic. So now when we invoke the filter function, we pass the input, that is the collection, and the callback, and it returns us a filtered object where we have this as the final answer. So let's dry run it. So we have our callback and we have our input. So inside input, our callback, we check for, as mentioned here, that the callback would be invoked on every element. So it's invoked on A, the value of A is 1 and it's greater than equal to 0. So we'll keep this. Then we have B, it's an object, so we'll go inside it. Then we have C as 2, again, the callback will return the truthy value, we'll keep it. D, it's -3, and which a callback fails, so we'll omit this. Then we have E, inside E we go to F and G, and so G is -4, so we will skip this. And if we check our output, we don't have F and E. That means that if we have to not only filter out the negative numbers, we have to filter out the negative objects, empty objects also. So in that case, we'll omit G, we'll omit F, and we'll also omit E, because F is an empty object and inside E, F is an empty object, so we'll remove the entire E object, and in H we'll keep I and J, and that would match our expected output. Okay, so let me just write this down. Our two requirements, that filter values greater than 0, or we have to omit values which are greater than 0 and filter empty objects too. Okay, so just to so when you approach a problem, it's better to go through the examples and write down everything important to the question, all the assumptions, all the requirements, or all the understanding of your understanding to the problem statement. It's going to help you when you write the actual code. Now if we go back to the next example, in this we again have an input object where A is 1, B a nested object, and so on. Let's say in this case our callback, that we have to only return the values that are string. So same logic applies here. A would be removed, we'll keep C, D is gone, G is gone, and as we have seen in the earlier example, since G is not there, F will not be there, and E will also be not there, and we'll have H. So if we see our final output, we'll have the B object, in that we have C, which is hello world, and we have h, which is good night moon, as the value. So next is the submission part. So let's go back to and start writing the code. So we saw that it takes two arguments, collection and callback. We already have that, and it returns an object. So let's create that object. We'll call it result maybe, and we'll return the result, or in this case we can call it filtered object, and we'll return this. Now as as we have discussed that if we have the primitive value, then we'll call the callback, and if it's a nested object, then we'll go inside it. That means depth first search. So we have to iteratively go inside every object, and we can do that by recursion. So let's say we define a new function called processing here, and this processing would take two arguments. One is the result and one is input. Now this processing function would do the heavy lifting for us. That means that it will call our callback, it would iterate over the objects, and it would do our depth first search via recursion. So we'll call this processing function. So it would take an result and input. So for the very first, when let's take this example, which is our first object. Our input, let's format it. I don't think it would format comments, so we have to do it manually. So if we see our input, then we have a. This is our initial input. So our processing will take the result, and we can pass our filtered object as the result. This is would be the final filtered object. So we'll pass the filtered object, which is an empty object for now, and for the first iteration our collection would act as our input, because that's the starting point. So we'll call here, let me scroll down a bit, or maybe okay. So in the processing, what we have to do is that we have to iterate over every property here and see that if it's a primitive value, then we have to call the callback, else iterate more. So we can do a for in loop for const property in input. Inside this we'll say that also for in loop, iterates over the what you call not just the direct properties but over the prototype properties. So we can put a check as a precautionary check, that object dot prototype dot has own property, and we can call it with input and property. So basically what happens is that when you call foreign, then iterate over the direct properties, and it also iterates over if you have something defined on, let's say, proto or object prototype, something also. Just to avoid that case, we are just checking that it should be a direct property inside this. So when we iterate over it, our property for the first case would be a, and that is a direct property. Now we can get the value of a. Let's say current is equal to input dot property. That's the current for now. Now we have to check. We have to check two cases, that current could be an object or it could be a primitive value. In these two cases, our assumption is that it would be an object or a primitive value. If it's a primitive object, then we have to iterate further or process further, but it's a primitive value, then we have to invoke the callback. So let's handle the primitive case first, or let's write both the cases. So if type of current is equal to object, and current is not equal to null, because type of null is also an object, so we'll avoid this case. Then we'll do some processing. Else if in this, now we know that it's not an object and it's not null, so we'll call the, so in this case it could be a non-primitive, maybe it's an array, but our assumption in the question is that it would be either an object or a primitive value, so we'll take that case. So we'll invoke our callback with current. If it returns a truthy value, let's move this inside. If it returns the truthy value, then in the result we'll set this property and we'll set the current value. So let me explain here. What happens here is that, so for the very first case, we get the property as a and current as 1. Okay, so when we invoke callback and we pass current, that is 1, it returns a true value. So that means our result should have this. That is what we saw in the here, that is what we saw in the filtered object, that a equal to 1, because it returns the truthy value. So it works. Now let's go back to the object case. So if we have an object, that means a is done. Now we go back to, now we are on the b part. So if it's b an object, then we have to iterate further. So how can we do that? We would call processing and we'll pass the current. We'll do a recursion call. But in this case, if we see the signature, the definition of processing, it takes two parameters. It takes a result and it takes an input. So for the first call, we provided the filtered object, but in this case, we are just providing the second parameter, which is input, the object on which we have to iterate. So what we can do here is that we can create a new object, let's say called nested object, and we'll call it an empty object and we'll pass it. So basically what happening here is that we are processing this object and we are creating an empty object. So let's say inside b we have a property called c and the value of c is 1. So when we call our callback with the 1 value, it returns true. So in the nested object, we are going to set c equal to 1. That's why we are passing the nested object. It is basically just processing this particular part. When we recursively call it, then when it comes to e, then it will just process this part. Inside f, it will process just this part. Same case for the h, it will just process this part. Now you might be wondering that we are not capturing the value of nested object. So we just defined it first, but we are not doing something like nested object equal to processing, because recursion is not returning anything in this case. We are doing so, you can do it, you can implement in a way where your recursion returns something, but in this case in JavaScript the objects are passed by reference. So if I mutate the object, this nested object in our processing, when it's invoked again, the result will have this nested object, and in JavaScript, since the objects are passed by reference, if you mutate that object, it would reflect back here. So that's why we are not collecting the output or not even returning in this particular case. So let me just clean it up. So this would handle our primitive case. It would handle c equal to 2, c equal to d minus 3, but we have to also take care that if g is not included, then we have to omit f and we have to omit e also. So how can we do that? By simply checking it. So if nested object is there and object, it should be a capital O, object dot keys nested object dot length, that means if we have the nested object and there are keys inside it, that means our nested object is not empty, because in case of f it would be an empty object. When returned, it would be an empty object because we are not including g, as -4 is empty. So we will omit this and we want to omit this also. We want to omit this also, and d is -3, so we just need values greater than equal to 0. We'll omit this, we'll include this, and in this case is also include, and due to this we'll include h also. So since we are omitting this, we have to omit f, and then as a side effect we have to omit e also. So we are just checking that if we have the nested object and the nested object dot keys dot length, then what are we going to do is result property equal to nested object. So this handles both our cases. We handle the primitive case and we are handling the nested object case also. Now if let's run the function so far, let's see. So Devtools platform provides test cases. So if you have some question, then you can run your solution against test cases. So we are passing two test cases, filtering non-negative numbers in a nested object and filtering strings in a object. So basically these are the two example cases we talked about. Now the third case is failing, which is invalid input parameters if the collection is invalid. So that's an edge case we need to take care of, that if our collection is invalid or if our callback is invalid. So how can we do that? Let's add this, is collection invalid. So let's say if we don't have the collection, or if collection is null, or let's format this much. Okay, this would be in, let's add one more, then we'll format it. Let's say type of collection, wait, let me scroll a bit. Let me move it into another line for readability. So if type of collection is not equal to object, or let's say if it's an array, we don't want to, we want to just iterate over objects for now, that's our assumption. If array dot is array dot collection, or the last, okay, so if that's the case, then it's invalid. So let's format it. So this is the collection invalid case. Let's say if our callback is invalid, is callback invalid, in that case what we are going to do, that if we don't have the callback, or if type of callback is not equal to function, wait, it's not a function, then we can early escape that if collection is invalid or is callback invalid, then we'll throw new type error stating invalid params, and we run this, and all our test cases are passing now. So this brings end to our video. I hope you were able to learn something from the solution I shared. If you feel I could have done something better, or you know a better way to solve the solution, then please try it out on the platform and submit your solution and share your submission link with me in the YouTube comments or on social media platforms. Also, if you feel and if you see any value in the work I'm doing, then please help us raise some content, some awareness around the content, around my efforts, by sharing the platform and the YouTube channel on social media platforms. I'm constantly adding new questions, new high quality questions I might add from different companies like Razorpay, AWS, Uber, LinkedIn, Google to the platform. The questions ranges from DSA, problem solving, UI based, and debugging around questions, and lots more. So I would request you to go to the Devtools Tech platform, try the questions, submit your solutions, share them with the world, and if you see any fixes, or if any bugs, any improvements, UI improvements, then please feel free to reach out to me. So till next time, see you, take care.